AAA electric motors, if you didn't see it. So guess what we're going to talk about today? We're going to talk about motors. My name is Bob Chupak. I manage the Anaheim branch, AAA has 3 stores. This is the main office in Los Angeles. Been here since what year?
34?
Well, we've been in business since 34. I think we've been in this location since late 50s, something like that. Anaheim opened up in 1992, and Riverside opened up, I think, in 2007. So we have 3 locations, we have the 3 counties covered for the most part. What we're known for is having practically any motor that you'll run across from mainly HVAC business. So anything refrigeration, heating, air conditioning, as well as exhaust fan, those types of motors, air compressor motors, stuff like that. We have some oven motors, but mainly HVAC. That's our bread and butter. And we carry a lot of motors, let's put it that way. Whereas you go to a supply house, there's plenty of supply houses around, or Grangers. They may have a lot of motors in their catalog, but they don't necessarily carry them. So when you come to AAA, Bobby can probably tell you that our success rate of giving you a suitable replacement is extremely high. Anyhow, I'm just going to give you a little background, little education about motors, so you don't have to fear them or anything like that. The wiring, we're not going to get much into wiring, but just a little information about the different types of motors. And one of the biggest things is the application of motors. There's no motor that's made for everything. I looked at our inventory one time in the Anaheim store. We have approximately, and this is about 5-6 years ago, we had approximately 2,400 different motors in Anaheim. 2,400 different motors, and like I said, that was several years ago. I would imagine it's probably 26, 27, 2,800 different motors that we stock. So that covers a lot of applications, a lot of needs that you'll have in the HVAC industry. I don't know what other supply houses carry. My guess, from what I've heard from other people, I would guess they probably have 100 to 200 maybe different motors. So you can see the difference there. If you're in Long Beach and you need a simple 3-speed 3rd horse blower motor, common sense would tell you to go to a supply house within a few miles and go get that motor, okay? But there are so many different motors, and it's getting more diverse by the year. There's so many special motors coming out that it's not that easy to keep up with. But we do our best. Once we see a motor a couple of times, AAA tries to incorporate that into their stock somehow, some way. We try to get that in our stock. So, can anybody here give me a definition of a motor? What do they think a definition of a motor is? Think about that. Electric motor. How would you define a motor? What is a motor?
Power thing. Takes electrical power turns to mechanical power.
You got it, exactly. You've been there before. All right. That's exactly what a motor is. It takes electrical power or electrical energy and turns it into mechanical, meaning it's going to do something. You're taking pure electricity and now it's going to move something physical, okay? Grab a book on the table here. I put several out. Grab a book. We're going to kind of fast forward through this book. This book you have, you can keep it. It's a very very handy basics about electric motors. And we're going to cover the different size motors, the different types of motors. Now we deal in, first of all, there's two different kinds of motors when you're talking about classifications. There's AC motors and there's DC. DC motors run off of a battery source. AC motors run off of alternating current, or your basic voltage that you have in your household. There's 115 volts. That's what you're most common with in your household. In commercial buildings, you have 230 volt. Even in your house, you have 230 volt for some appliances. If you have a swimming pool, your pool pump may very well be 230 volt single phase. Yeah.
A car would be a DC motor?
A car is, that's a DC motor. Runs off a battery source. That's correct. That's a gasoline engine, but even electric cars, that's a DC. That's a DC motor. AAA deals in AC motors only. We do not get into DC, because that's what's in the HVAC industry, is AC motors. If we start at the beginning, open up the page, let's start with page 5. It says motor types. Well, if you look at page 4, you see single phase and 3-phase voltages. Okay, we've determined that there's a DC motor and an AC motor. We are AC only. When you're talking AC now, you're talking single phase and you're talking 3-phase. That's the two types of AC motors. 3-phase is always commercial. Our building here has 3-phase power. Your house has single-phase power only. Residential, single-phase. Commercial is you relate commercial buildings to 3-phase power. So the voltage, when you hear 115 volts, that's going to be single-phase. When you start hearing 460 volt, that's going to be commercial. Okay, 230 volt could be either way. It could be single-phase, 3-phase. Okay, then you go to page 5, you have motor types. Now I'm going to pass these motors around. The first one there is a shaded pole. This is the least efficient motor that's still made. And these will be phased out probably in the next few years. There probably won't be a shaded pole motor any longer. These are about...
It's usually what they have on blowers, right? Blower motors?
Small, these are direct drive only. In other words, they're not a belt drive application. It's a direct drive. So whatever, a shaded pole is going to turn whatever is connected to the shaft directly. Okay? So usually a little small fan of some sort, or squirrel cage. Shaded pole motors are roughly 30 to 40% efficient. Very inefficient motors, okay? I'll pass it around. And the way you can recognize a shaded pole motor is you'll see copper coils, the windings. You'll see they're separated. They're all separated coils. That's a shaded pole. And you can also notice the number of coils that you see in there. This particular motor has 6 coils, and we'll get into that a little bit later, what that means. Turn the page to page 6, and that's a permanent split capacitor motor. Now I have okay, this is a double shaft version of a permanent split capacitor. This is a capacitor that's on this one is attached to the motor. Not all PS, they call them, the abbreviation for them are PSC motors. Not all motors have a cap mounted on them. They're usually a separate item that you buy. In this case, this particular motor has a cap that's already incorporated in the construction of the motor and sold this way. And if you look at this motor, this is beautiful motor for demonstration because you're going to see copper windings, and then you're going to see on the inside, if you notice, there's green windings, green colored windings, okay? This is permanent split capacitor has a start winding and a run winding. So in this case, if you counted the copper coils, or you can count the green coils, there's gonna be an equal amount. So just take note of that as you pass that around. Okay, that's a permanent split capacitor motor. Next is a split phase. One more thing about a permanent split, those are also associated with a direct drive type of application, meaning you're going to have a fan blade or a squirrel cage on that motor. You're not going to see a pulley and a belt on a shaded pole or a PSC motor. Those are direct drive motors. Now a PSC motor is twice the efficiency of a shaded pole. Okay, that's roughly 30% efficient. A PSC is like 60% efficient. Okay, so when I said that they're going to phase these shaded pole motors out, that's what they're in the process of doing right now. A lot of these shaded pole motors are being made like this little motor here. You would never, 25 years ago, you rarely would see a little 3-inch motor with a capacitor on it. They were always shaded pole motors. But now you're seeing more and more motors with capacitors on them because they're phasing out the shaded pole. So even though that's 30%, that's 60%, that's a lot more efficient, it's still not very efficient, okay? 60% doesn't even sound efficient. This is a capacitor start motor. It's got a cap on top. We're on the split phase section here, okay? A capacitor start motor is, which I think you'll find on probably the next page. Is it on the next page or not? Well, yeah, maybe not. Okay, they skipped the cap. This is a Fasco book. I don't think they make a capacitor start motor, so.
Page 5.
Is it on there? Oh, at the bottom. Okay, capacitor start. Yeah, Fasco doesn't even make a capacitor start motor, I'm aware of. But anyhow, a capacitor start motor and a split phase are almost identical, except for the fact that a capacitor start motor incorporates a capacitor that stores voltage. So when you put power to it, the motor starts immediately. Within a second or two, this motor's up to full speed. Whereas a split phase motor, when you put power to it, it's going to go. It takes 3 or 4 or 5 seconds to get up to speed. Okay, that's the only difference between a split phase and a capacitor start. And these types of motors, you'll see in here, in the back of the motor is a stationary switch. And if I had the rotor, I don't have the rotor here. The rotor will have a rotating switch, and that's we're not going to get into that. But a split phase or a capacitor start motor will have those two switches installed usually in the rear of the motor. The shaft will be out of this end. The switches will be in the back end. Okay, so that's two more types of motors. Now, these are associated with belt drive applications. And these motors here will have, and we're going to talk about this later, these motors are belt drive motors are self-cooled. Okay, as they're running, they're turning a pulley, which is turning a belt, which is attached to something else, usually a fan. So this motor is turning a fan. There's no air cooling this motor. So these motors are what you call self-cooling. They don't need a fan to aid in the cooling, as do these other motors. And in a few minutes, we'll get to that. We'll get to that subject a little deeper. So you can pass that motor around. Okay, and then the last type, well, it won't be the last, because since these books were produced, there's now a new type of motor. But the other type, all these motors here that I passed around so far are all single-phase motors. Shaded pole, PSC, split phase, and capacitor start, which is simply a split-phase motor with a capacitor. This is a three-phase motor. I'm not going to pass this around, it's a little heavy. This is a three-phase motor. This takes three-phase power. These are the most efficient motors that are made. Okay, so when you're talking three-phase motors, usually mentally you're associating them with 1 horsepower and above. Yes.
Like on those where the capacitor is integrated into the motor.
if it wasn't starting, is there a way that you could just change the capacitor, or you have to change the whole motor, huh?
No, sometimes capacitors do go bad. When they do go bad, a lot of times it's more of a symptom of
Like you'd have like bad amp draw or something?
yeah, it's usually a symptom of something else that's going wrong when a capacitor. Sometimes they do blow, but usually when it's a start capacitor that goes bad, there's something that might have caused it. Okay, something could be in the switching mechanism of the motor, could be an overload situation, could be a voltage, could be a lot of things that would cause a capacitor to go. But yeah, if the capacitor is bad, you could simply change the capacitor, but then when it blows again a week or two later, you know there's something else going on. Three-phase motors are, like I said, associated with roughly 1 horsepower and larger. However, they're all are smaller three-phase, smaller than 1 horse. But when you get into larger motors, which this is our rewind department actually, there's large motors. I mean, we wind up to we'll go up to 250 horsepower, which is quite large. But any motor of that size, when you're talking 10 horse, 20 horse, 50 horse, you're going to have a three-phase motor for the most part. Single-phase motors, I think they used to make up to 15 horse. I think it's 10 horse now. There may be somebody that makes a 15 horse because they're so inefficient. They just don't make large single-phase motors. Very inefficient. Once you get past about 1.5 horses in a single phase, the efficiency drops way off. Three-phase motors, the larger the horsepower, the more efficient they are. Okay, so that's we have 4 types of single-phase motors, and then we have three-phase. Now, three-phase can be belt drive or direct drive. You'll find them in the larger horsepowers. Are typically either they're coupled up to something or they're a belt drive. Yeah.
Sorry, I interrupted. But I still have yet to get like a grasp on the difference between a single phase and a three-phase motor. What makes it a three-phase? What makes it?
It's how it's wound. If you'll see, it's three sets of windings that are incorporated. Okay, they're intertwined. You see the difference? There's no separation in the windings. There's 3 overlapping windings. Okay, it's like I said, it's the most efficient motor. Now we'll get into that type of thing, but you can simply very easily see compared to these other styles. You see in this motor here, for instance, what's your name? Robert. You see how you have you have 4 outside coils and 4 inside coils. These are starts, these are runs. Okay, so you don't see any separation in a three-phase motor. They're intertwined. They're overlapping, continuous windings.
So that's, I guess, what I'm trying to get at. Let's see if I can put it in terms that it's unintelligible. How? No, I'm sorry. Go ahead. I can't even say. I'm trying to. In a single phase, the run and the start. It's the same thing in a three-phase.
No, there's no run and no start. No. In a single-phase motor, in a split-phase capacitor start and a PSC, there's 2 windings. There's a run winding and a start winding. Okay. Three-phase motor is three-phase. Completely different construction of three-phase. Okay. These motors are up into the 90% efficiency range. You may get like a 10 horse motor, it's 92. I got catalogs that show you the efficiencies. 10 horse motor may be like 92.5, and you get up to 20 horsepower motors and they're 93.5, and 50 and 60 horsepower motors might be 95%. Very efficient when you're talking, especially compared to these other types of motors. So you can see where the larger motors they get with three-phase.
When you say efficiency, you're talking about how much energy is converted in
Right, per
revolution?
well, no, not per revolution, but for the cost of the electricity, the amount of power putting in, the amount of power that the motor's putting out. Okay. All right, now, yes.
Three-phase motors don't need capacitors.
No capacitors.
But the single-phase do need capacitors, right?
A capacitor, start needs a capacitor, and a PSC needs a capacitor. Shaded pole does not. 40 58, 56. They're 2-digit frame numbers. Those are all called fractional frames, fractional horsepower motors. Any 2-digit frame is called a fractional. Even though it may be a 2 horsepower, you could have a 2 horsepower in a 56 frame, but it's still considered a fractional horsepower. When you get to the 3-phase larger motors, like I said earlier, 1 horse and up typically, the numbers begin with 3 digits, like 143T, 145T, 256T. There's old U frames from the 60s, 256U, 324. Any 3-digit number, they call those an integral frame. Okay? Any integral frame motor is a 3-digit frame which you associate with larger motors, typically belt drive or coupled up to a pump, coupled up to a compressor. Okay, let's move on. I'm sorry?
On the 3-phase.
Yes.
Single-phase one. Like, if you change the frequency, I know for sure that electricity use a lot of wind from different countries. Use 50 hertz frequency. The top changes on those. But in the 3-phase, the newer ones, they have rated like, they have
50 or 60.
Yeah.
There are single-phase motors as well,
Okay.
designed for 50 and 60, yeah.
You have them here?
I know I have some in my Anaheim store. I have some because I had a company that buys them from me all the time, because they ship them overseas. Yeah, A.O. Smith makes it. It's rated. It's a single phase. It's rated for 50 or 60
And
hertz.
the torque is the same, regardless of the.
Same torque, yeah. Okay, motor enclosures, extremely important. If you're going to be in this industry, this is something that you want to really get a grasp of. And this is where I like to talk about application. You'll see on page 8, it shows a shaft up motor and a shaft down. And on page 9, it shows totally enclosed, and it's abbreviated non-ventilated TENV. There's also TEAO. There's that second picture down on page 9. You see that motor's openly ventilated, a lot of holes in it, like this motor here. You see all the holes all the way around. There's lots of holes. There's totally enclosed fan cooled, which I need a motor, maybe a D134 or something. Bobby, can you grab that? And then open drip proof, which is different than this, and I'll explain that in a minute. Okay, first of all, shaft up motors. I don't have a great example. This will do. The shaft up motors will have an enclosed end bell. Okay, these are designed for shaft up. A condenser, this is an indoor motor, but the shaft up motor will have an enclosed end bell here and will have enclosure on the sides. So right here, this is what I'm talking about right here. So you have enclosed on the top and on the sides, the back is open, okay? Anytime you're replacing a motor, you want to have a motor as open as possible. Okay? The better a motor can breathe and get rid of the heat, the longer it's going to last. Okay? So if you have a shaft up application, this is what AAA would sell you. Okay? With the back end open. So this motor sits outdoors like this here. And we recommend you put a rain slinger as extra protection for the front bearing. So you'd have a little rain slinger on the front. This is all enclosed here, here, and here. Only the back is open. Okay? So you're protected against rain.
How does air circulate when it comes from outside?
How does air circulate?
Yeah, because hot air has to come out. It only travels one way.
Well, heat does go up. There's no doubt about that. Heat rises. But having that butt end open, believe me, and the rotor's going to have little fins on it. If you look at a rotor, you see the rotor, how it's got fins? You see those fins? So, yeah, it is pushing air. So that would be a shaft up motor, okay? If you go to the bottom of page 8, a shaft down motor. Now this motor is going to be fully enclosed. In other words, this is enclosed from all ends, okay? Now, if you'll see here, there's a hole. There's a hole there, okay? And that's very important because a lot of motors you'll buy will have a plug in that hole, okay? If you're mounting the motor shaft down, you remove this plug. Anybody tell me why?
Ventilation.
Not oil. Huh?
Ventilation.
Not ventilation. It's like a weep hole. Any enclosed device like this that's outdoors is going to build up condensation inside the motor, okay? If it's got nowhere to go, what's going to happen? Motor's going to get very wet inside, and that's going to really shorten the life of your motor. We see motors come in like this, and guy brings it in, he sets it on the counter, might be a little bit rusty, but it looks fairly new. That's the first thing I look at. The plug's still there. The motor usually lasts a year, maybe a year and a half, and the motor's gone. It's because it's all wet on the inside. So, very important that you pull that plug.
So that's for, downward, right?
Right, if you're mounted down, you pull this. You'll see motor, see it's got a hole on each end? You can technically use this motor for shaft up as well, and in which case you would pull the back plug. You follow me? And this plug, you would need to plug this hole up, or put a rain shield on it. Now horizontal mount, you could use this motor horizontal, you could technically use this. I wouldn't recommend it. Again, you always want to use the motor as open as you can. If you're horizontal, you would use this, or even with both end bells open. There's, you know, there's a little bit more to it, but anyhow, applications and enclosures are extremely important. Air conditioning motors can be more enclosed, and that's how they're designed. And the way that the air exits, those motors are designed and cooled very efficiently. Refrigeration is a little bit different. Refrigeration, condenser fan motors pull hot air back directly across the motor. They pull that hot air from a compressor right back across. So those motors tend to need to be a little bit more openly ventilated. That's getting a little bit more in depth, but application is very important. These motors that you buy across the counter, whether here or anywhere else, should last at least 10 years. If they're only lasting 3 or 4 years, you more than likely got a wrong application. You got the wrong motor for the application. Okay, the open motors, obviously, this is a fully open motor, this is an indoor motor, okay, where it's not out in the weather at all. Same with this here, not out in the weather, very open. Drip-proof motor, this is considered a drip-proof motor here. Okay, this, I'm kind of surprised it doesn't have holes down here. Usually you'll have motors, you'll have holes. If you look at the picture even, you'll see holes on the bottom half and in the end bells, okay? That's called drip-proof, and what that means is if water comes straight down on that motor, it'll run off and not go into the motor. Now, we've all seen rain. Does it always rain straight down? Doesn't always rain straight down. So that's, depending on the type of motor, where you're using it, that may not be the best. A drip-proof motor may not be best for outdoor. They make totally enclosed motors for outdoor, for belt drive as well. Next page, if you want to go, I think we're done with totally enclosed fan cooler. I'm sorry, last one there. We haven't covered yet. This is what they call a mechanical duty motor. Now, I mentioned it earlier when I was talking split phase and capacitor start and 3-phase. These motors are all self-cooling motors. These motors need air over to stay cool. So they depend on having a fan right on the shaft that as it's moving air to do what it needs to do, it's also that same air is help cooling the motor. Now there's applications where you have a motor and you'll have a plate that it's mounted to, and then on the opposite side of that motor you'll have a fan. You'll see this a lot in exhaust fans. rooftop fans, whatnot, where motor may be getting rained on, and the fan is down below. These will typically have covers though. But anyhow, you need a mechanical duty motor driving that little fan, okay? And what this motor here, you'll see, has its own little fan on the back of it. This motor does not have that, this motor does not. None of these motors here have that cooling fan like this has. Okay, this is called a mechanical duty motor, meaning that it's cooling itself. So you could have that in applications. We see one of the most commonly, what word I want to use there, wrong motor we see all the time come in on exhaust fans, rooftop exhaust fans. People go to some other places to get motors, and they'll see a motor like this, not recognizing that it might be off of a dome exhaust, for instance, where it's not. They'll just sell you a motor that has the same RPM, it's physically the same voltage. They'll sell it to you, and it's not the right motor. Okay, very common problem that we see in our line of work here. Motor bearings on page 10. Okay, you have sleeve bearing motors, sleeve bearing or bushing type bearings. This is a sleeve bearing motor. Now if you'll notice, I can pass this around again, it's got in and out play. When you pull on it, it's in and out, it's got an in and out play to it, okay? Just ever so slightly, maybe 1/8 of an inch. But that's normal for a sleeve bearing motor. And what that is a bronze bushing, and it's got you oil it, it's got an oil pad around the bearing, and that oil pad over the years feeds oil to that bronze bushing, and the shaft spins inside the bearing. The bearing is stationary. The shaft spins on that film of oil, okay? These need to be maintained over the years, or obviously as that pad that supplies the oil, as that oil dries up, now you got metal on metal, and then eventually the bearing is going to go bad very quickly. It's a bronze bushing or bronze bearing, and it's very soft material, and it'll go bad quickly once the oil dries up. So they do have oil ports that you can oil them. You see these a lot in older furnaces and applications like that, and nobody typically oils them. So they just go until their bearings go bad. Usually the first thing probably goes bad. The other version of a bearing is a ball bearing, which is what these are. If you try to move the shaft in and out, there's no in and out play. So if I get people calling me sometimes, they'll say, could you tell me if this motor is a ball bearing or not? How can I tell? Or they'll want to give me a model number. Can you look up some, I got a, GE model number. Can you tell me if it's ball bearing or not? And I'll just say, you know what, just go grab the shaft. You can go in and out. It's not a ball bearing. If you can't move that shaft in and out, it's ball bearing. If you can, it's a sleeve bearing. Okay? That's simple. So you can tell what a motor is just simply by that. Ball bearing, any larger motor is going to have ball bearings in it. Okay? Small motors could be ball or sleeve. Everything's kind of going to ball bearing because a lot of manufacturing is now overseas. They're putting ball bearings in everything. Okay? They're bearings that are, for the most part made in, foreign countries, China being probably the leading one. And, they're going into motors, they're making motors cheaper, they're just throwing ball bearing motors out there and for everything now, so it's just kind of the way the industry's kind of going.
Is it the best type?
Well, for heavier, larger applications it is, but they're putting them in everything now. Typically, the reason for sleeve bearing is sleeve bearing motors are quieter. They run very quiet, whereas a ball bearing motor, typically you'd only have an outdoor motor ball bearing. All your indoor motors would be sleeve, okay, because of the noise. Not that the motor, a ball bearing motor is terribly noisy, but if you had a couple motors in your house, maybe the furnace motor and an exhaust fan, if they were all ball bearing, you would get a lot of bearing noise. you know, in your home. Nobody wants any kind of, you know, everybody wants to hear the TV, not the motor running. Page 12, thermal protectors. All these fan motors that we have out here are thermally protected, meaning they all have an overload, normally 180-degree overload. So once the motor, if the motor was overloaded for whatever reason, maybe sometimes your voltage drops to the supply. There's a lot of reasons, but if a motor gets overloaded, it will start running hot. Okay, if it gets to the point around 180 degrees or higher, the motor has its own overload in there. The motor will kick out until it cools down, and then it's an automatic overload. It'll kick on by itself again. But there's a problem that's causing it, and it's a problem that needs to get diagnosed. What was I going to say? There are motors with no overloads. Your larger three-phase motors do not come with overloads. Three-phase motors run off of what they call magnetic starters, or disconnects, and they run off of a three-phase contactor. Now you can have protection. You can buy protection from a supply house to protect this motor electrically. You can protect it thermally, but typically what causes a motor to overheat is usually a high amp draw on the motor. So usually when you're protecting a three-phase motor, you're protecting the amperage that the motor. If a motor is, for instance, rated at 5 amps, you want to be at 5 amps or slightly under. If that motor, for whatever reason, starts drawing 6, 7 amps, it's going to get hot. Okay, and that motor's going to keep running hot until it has no overload. It's going to keep going until eventually that varnish on the windings is going to break down, and that's what happens over the years. That varnish that's on the winding, it breaks down, and now you have metal to metal, and it shorts out or grounds out, and the motor's fried, and you need to replace the motor. Okay, so you do need protection for larger motors. Small fan motors are self-protected for temperature. All right, we can go next to lubrication. Don't need to spend any time there. Capacitors we kind of covered. Start capacitors, run capacitors. Page 18, if you want to go to there, you'll see the picture there where it shows the coils. You see that top picture is a shaded pole motor. You recognize that? That's a shaded pole. It's got 4 separate windings, nothing overlapping. That picture there, how many coils you see in that picture? There's 4 coils. We'll get to that in a minute. The bottom picture is like a PSC style motor. It has overlapping windings, and it's hard to see there how many coils, but it looks like about 4. But you have an inside and an outside. We can skip past 20 and 21, talks about horsepower. Page 22, let's go to 22. Mechanical characteristics. Okay, that's covering, you see the second fact, it says the different sizes, 3 1/3, 4 7/16, that's one of the middle sizes I told you. There's no frame number assigned to it. They're not real common. The 5-inch we covered, the 5 5/8 we covered. But what this page is kind of getting to is when you're out in the field and you're going to replace a bad motor, there's a lot of things you need to pay attention to. Okay, and the more that you're in the industry, the more you'll be aware, because you're going to go to somewhere and they're going to sell you the wrong part. Okay, so you're going to be a little bit more wary of what you're looking at. Okay, pay a little bit more attention to how a motor mounts. There's different means of mounting. Okay, this motor here, very common mounting is what they call belly mount or belly band. where there's a bracket that attaches. There may be short legs, maybe long legs, but the motor's clamped. The main part. Okay, we've seen that this motor, if you remember when you passed around, had 6 coils. This had 4. You've seen the copper and the green, there was 4 of each. That's a 4-pole motor. Motors in our industries, you'll see on the bottom of the page, 2, 4, 6, and 8. A 2-pole motor is associated with a 3,000 RPM motor. Okay? The less number of windings, if you can imagine electricity going through those coils, there's only 2 to go through, it's going to go through quicker. Boom, 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 boom. You got a 4-winding motor, you got to go through 4. So the motor's going to run slower, isn't it? It's got to travel through 4 coils. 6-pole motor is going to run even slower through 6. 8-pole motor, which is like 825 RPM roughly, it's got to go through 8 coils, so it's slower. Does that make sense? Okay. The slower the motor, however, the more torque it has. If you had a half-horse motor here that was 3,000 RPM, was a 2-pole motor, I could hold the shaft, put power to it, and it probably wouldn't go. It wouldn't take off. And that's starting torque. It's just like I'm just trying to explain starting torque to you. A 4-pole motor, if this was a 4-pole, I could probably still hold it. If it was a 6-pole half-horse, I might be able to hold it for a second and it probably would take off. An 8-pole would probably just start tearing into my hand right away. If you can understand, if that helps you, you just kind of visualize what torque is. So the slower the motor, the more torque it has. Yeah.
So torque is like the power.
Right.
That it gets earned.
Right. That when that electricity is going through there, it's transmitting that electricity from those copper coils to the rotor, and that transfer is stronger in an 8-pole motor. Okay, you understand? To get that rotor going. Okay. High slip motors, we're not going to talk about that. BTU ratings, that's beyond what I want to get into. That's you guys will probably learn about that in your class. Page 27, cooling motors. I think we've kind of discussed that pretty good. Temperatures. We've gone over that. And then we're going to go to removing motors on page 31, which I started to talk on a little earlier. But go to that, and you guys can look over this later on at your convenience. But when you've been out in the field and you're going to somewhere to get a replacement part, whether it's a motor or anything, you always want to be very visual. In other words, you want to mark your wires, you want to know where the wires are going, what color is going where. You want to take notice to how, in motor, speaking of motors, how the motor's held, okay, how the motor, the position it's in, the direction, the rotation. You might get a pen or something and just mark the rotation if the motors weren't turning this way.
What if it's turning the wrong way?
Well, still, you want to mark the rotation, what you found. It could help. Let's put it this way. It could lead you, if somebody gave you a part that's going the wrong way, say, hey, how come? And then if you look into it further, maybe you're right. Maybe the motor was running the wrong way. But at least ask that question.
Maybe a mark CW, CCW on them. When you're looking at it,
Some motors do and some motors don't.
they look at it counted from looking at the motor.
Shaft end?
Yeah.
Okay. Very, very good question. He asked, which way do you look at a motor to determine the rotation? There's no correct way. Okay? Most motor manufacturers look at the lead end. Okay? I've always adopted the lead end. Pretty much everybody at AAA will look at the lead end. And there's a reason for that. So if this motor were turning in this rotation, that would be CCW LE. In other words, lead end. The opposite would be shaft end. If we're going this way, the same way, it's CW SE, or shaft end. The reason it's to me, it makes most sense to look at the lead end is because if you have a double shaft motor, what direction is this going? If it's turning this way, what's it going? You can't say CW shaft end because it's going CCW on this shaft, right? CCW on this shaft is CW on this shaft. So what else you got to look at to determine the rotation? You have the leads, which side the leads are going on. So if you look at this motor, looking from where the side that the leads are on, you would say this motor is going CCW lead end. So if you look at the lead end, in my opinion, it's the best way to look at it. So that way, under any circumstance, there's no confusion. But yeah, be very visual in what you're doing, how things are, you know, like I said, wired in, which way they turn, how they're mounted. Pay very close attention to that. It may save yourself, you might save yourself a few hours and a lot of headaches and grief if you take notice of things like that. Page 32 is a checklist of things you should be looking for when you're replacing a motor. Like I said, how's it mounted? What type of motor is it? What kind of ventilation? Does it have air over? Is it in the airstream? How many speeds does it have? The direction of the motor? Well, let's touch on horsepower real quick. When you're replacing motors, a motor will have a horsepower rating and it'll have an amp rating. This motor here is a half horse, and at 230 volt it's 3.5 amps. Okay? At 230 volt single phase, you may go to a place that is going to replace this with a half horse motor that's 3 amps. And you might get out to the job, but now it's half horse, it's 230, everything looks great, you didn't check the amps. You fire it up, you put the fan blade or whatever's on it, and then you get your amp, after you install the motor, everything's just right. The fan's secure and all that, everything's safe. You start it up, obviously, right? And now you want to check the running amps. And it's rated for 3 amps, the new motor you got, and it's running 3.3. It's like, well, what's going on? And you call up and you say, well, this motor you sold me is over amping, blah, blah, blah. Amps tell the true story of a motor, okay? The amperage of a motor tells you the true power that motor has. Okay, you go by amps more than horsepower. If you ever open up Sunday paper and you open up to Pep Boys pamphlet in the middle, a little flyer, and they'll have big sale this week, 5 horse compressors for $200 or whatever. You can't even buy a motor 5 horse for $200. So how is that? If you look at the motor, it says 5 horsepower on it, but the amps are the amps of a 2 horse. They can put anything they want on a motor. So be leery of that. Don't just look at horsepower and voltage in RPM. Look at the amps. Okay? Now, if it's a 3.5 and somebody's selling you a 3.4, that's fine. Okay? But there are big discrepancies in motors, and you need to pay attention to that. Yeah.
So, like, basically, the amps are the power behind it, and
That tells the
horsepower.
true power of the motor, right? If a motor is a 3.5 amp, it's stronger than a motor that's a 3.0 amp. It's going to handle a heavier load.
So horsepowers don't really matter.
Don't just look at horsepower is what I'm telling you. Be cautious of that. There's a lot of OEMs out there. OEMs is original motors that are in units. There's a lot of units out there that may have a half horse that are, I've seen half horse motors that are 4.2 amps. Okay? You don't want to go to a supply house and just get a half horse motor that's 3.5. Many a times I don't have a suitable motor at half horse that's that 4.2 amps I'm looking for in a certain application or certain mounting. I'll bump it to a 3/4 horse. And a 3/4 horse might be 4.4. In other words, I want to make sure that guy does not have a problem, okay? I would rather overkill it a tad than have a guy have to call me or have to come back because the motor I sold them isn't doing the job it's supposed to do, okay? On that subject, I brought a couple fan blades out here, and the reason I did is because you see these two blades, they may look similar, they look fairly similar. They're the same diameter, they're both 20 inches, okay? Can anybody see a difference in these two? This one has a little bit more pitch. This is a 33 degree, it tells you right on there 20, 33. That's 20 inch, 33 diameter. This one says 20, 27. Big difference, okay? This blade at 1075, 1075 is probably your most common fan speed that you'll see. This blade requires a third horse at 1075. This one requires a 1/6. Okay? Doesn't look a whole lot different, does it? Not much different. But be very leery of that, and don't be afraid to ask if you're getting a motor and somebody's handing you a blade to say, are you sure that motor's going to handle that pitch? You know, ask. Make the guy look it up. There's charts that we all have that sell these blades, and they'll show you at a certain RPM and which pitch blade, it tells you how much horsepower you need to turn that blade. Okay, that's one of the most abused things that we see when people come in with a motor that's not very old, that's failed already. And there's an aftermarket fan blade on there that's too much pitch for the motor. So, you know, again, that was somebody was negligent when they sold that motor in that fan blade combination. Okay. Another thing I'm going to tell you too, while I'm on the subject, is when you're getting a new motor, a little fan motor such as this, which you'll see these all the time in this industry. I highly suggest getting a new fan blade or squirrel cage, whatever it may be. These are like $35, $40 items. The motor's probably double that, in that range, maybe $80, $100 motor, 100, you know. But the main thing is, it may prevent a callback, okay? Callbacks cost money, okay? People in this industry don't work for free. So that's money lost. Every time somebody brings a new motor, not every time, but so often, I sold this motor to 8 months ago, brings it back, hey, I got a problem with the bearings. It's like, I look up the invoice, they bought a motor, they bought a capacitor, did not buy a fan blade. So often, almost every time. Same with the squirrel cage motor. Bought a motor, bought a capacitor, didn't replace the squirrel cage. They got a callback 8 months later. Hey, even if I give them a motor, and I don't have to, because I could easily see bearings don't go out in 8 months. I know that. Typically, I'll give a guy and I'll tell him, listen, you need to get, I'll give you a motor, but only if you buy a new blade or new fan, okay? That's a fair proposition. But even if I do give the guy a new motor, he's lost hours. He's lost hours on that job. Customer doesn't pay for that. That's a callback. So these types of small applications, you're talking $30, $40 fans. Compared to what a company charges per hour for you to go out on a service call and the gas and all that's associated with, replace the fan. Replace the fan. Okay, let's zip through here. I think we're getting almost done here. Motor wiring, always pay attention to your wiring. You're removing a motor. Mark what wire went where. Now you guys all got smartphones.
Yeah.
Take pictures. That's invaluable. Take a picture of the wiring. Take a picture of the nameplate of the motor. Take a picture of the motor still in the unit. My goodness, that's such a nice thing nowadays. Years ago, we have to ask 1,000 questions to get, you know, they say a picture's worth 1,000 words. It's so true. I mean, guy pulls out his phone and, oh, here it is. All my questions are answered with one picture. Say that again now?
And there's a legal alone, because they sometimes put it out and all that, because the one sometimes they sell it, I don't know, guys, but.
No. Lao fans are quality fans. Most everybody sells Lao.
And they cheap too when you
I mean,
change the motor.
it's easier, I mean, to be honest, but these people that technicians do that and they find their things.
Well, yeah, you're saving a little time. So yeah, it's something you got to sand on the shaft, grease it up, fight with it.
They still do that because something else is.
Yeah, I kind of chuckle when I see people. Some people come in, and God, we used to do it all the time. I remember I worked here years ago. We were back on his back vise all day long. Everybody went. That was common practice to save the old fan. That was just common practice. Not so anymore. It just doesn't make any sense. The time involved and the risk of like a callback. Nowadays, labor is just too expensive. Not like it used to be. If you go, you guys can look through this, as you want. It goes into contactors that I mentioned earlier. Induced draft blowers. That's what this is off of. This is off of a pretty large carrier induced draft. Well, most of them are a little bit smaller. Nowadays, you kind of replace the whole blower section, not just the motor. And it goes into squirrel cages, fan blades, fan laws. It's a little above. And then there's a little glossary in the back, which is, I would highly recommend that you guys went through that and read through it. Spend a little time with that. That way it's just some lingo that you should get accustomed to if you're going to be in this industry. And it gives a little description of what each of those things mean. Other than that, it's about. Let's touch on this motor. This is a new motor that's only been out. I don't know. What do you think? I don't know if you know, Bobby. Maybe 6-8 years, something like that now. It's called an ECM. Okay. Now it's complicated because it's wound like a DC motor. It checks out like a 3-phase motor, and it runs off a single-phase power, AC. So it's a complicated little booger, and they're expensive. And as they're finding out, there's this back end belt incorporates some electronics. It's got a rectifier. It's got some little capacitors. They're finding out that these aren't holding up the moisture too well. And in the airstream, there is moisture in air conditioning units. So these motors are lasting on average 4 or 5 years. And they come in expensive units. What they call high SEER units, which are your higher efficient units. These are very efficient motors. These are replacing the PSC motors, which I told you these are roughly 30 or so percent efficiency. These are 60, and that's on high speed. As you go down to lower speeds, they lose efficiency on multiple speed. These are 80% efficient, and they vary. You can vary the speeds on these very easily, and they maintain 80% efficiency at any speed. So the idea of these is terrific, but they still got some problems to iron out. Yeah, this is the new thing. And then even in 3-phase motors, Marathon has now in their catalog a motor called the Cymax, which is like this. It's a 3-phase motor that I think they make up to 50 horse right now. And it's DC wound. All your larger motors nowadays are running off what they call VFDs, or variable frequency devices. They're drives, what they call a frequency drive. And what you're able to do with that is you're able to ramp a motor up. You're able, when it senses certain conditions, it may be in the weather or whatever you're using it for, the motor can run slower. When it doesn't have to run fast, it can run faster when it needs to. It can run full speed when it needs to. So you can see the energy savings there. That's so much is going to, and 3-phase motors are running off that. That's the same principle that this is, same thing. And what that does is it takes on a three-phase motor, a drive, the power goes into the drive, and the drive converts that AC power into DC, and then in a three-phase motor, it has to convert DC.
Now, how exactly is that?
Well, it's even more efficient now. Everything's just getting more and more, and it's just more and more efficient. Now, there's never been a DC motor that they could make in the same frame sizes as they could make an AC motor. They could make AC motors relatively compact. DC motors were monsters, okay? The Cymax now is a DC wound motor that needs to run off an inverter that they can now make in the same footprint as a three-phase. So that's kind of like the next newest technology. Right now it's expensive, but it is out there. So you're seeing the change in the technology as far as motors is concerned. So you got this here that they still got some problems with, and then now you have the bigger motors you have what Marathon calls a Cymax. That's just a brand name they put on it. But anyhow, it's about all I can think of. Anybody have any questions at all, or? Yeah.
That actual conversion process from DC to AC, what kind of power drop are we talking about when it converts from AC?
Oh boy, I couldn't answer any kind of question like that. I'm not that big into. That's in the drive itself. It's not much of a drop because these motors are, like I said, they're 90-some% efficient. And these drives, what they're able to do with the motors, of slowing them down and speeding them up, it's only making everything more efficient. I don't know. I don't think there's much power drop at all, as far as I know. But I couldn't answer that. I just don't know. Anybody else?
Questions, folks?
Boy, I must have did a good job.
Well, Bob?
I don't mean to hold anybody up. Back to that three-phase and single-phase I was asking earlier. What's the inherent difference in start? What's going on a single-phase motor that's not going on in a three-phase, or what's going on in a three-phase that's not going on in a single?
Well, three-phase motor is a much stronger motor.
Yeah.
Okay, much as far as torque, we're talking torque again. That's starting power. Three-phase motors, there's 3 windings that's incorporating. Okay, it's a stronger torque, more efficient. Like I said, in larger motors, that's why you'll see three-phase motors. Single-phase motors, typically used in the industry, you only see single-phase up to 2 horse. There are 3 horse, there are 5 horse, plenty of them, like on air compressors. Rarely do we occasionally see something over 5 horse, not very often, but all small horsepowers is because they are not efficient, and they're most small motors are used for whether it's residential or just small applications. That's where you want to use single-phase motor. Condenser fans on your houses, or even a lot of commercial, you see a lot of single-phase. Small motors, small units. I don't know if I'm answering your question or not.
I guess what I'm trying to say is there's no inherent difference in the theory behind.
No.
It's the same, it's just more compact.
Right.
So
right.
it's not like. How can I explain?
No, the three-phase power, it's three-phase power.
Okay.
It's when you're talking three-phase, you're talking 230 or 460 volts, three-phase. Okay, it's more power. These motors run off a 115 or 230 single-phase.
Okay.
You have 2 hot wires. This has 3 windings. It's hard to get. You're getting into the windings concepts and all that.
Yeah.
I probably can't answer your question like as well as you'd like it to be answered, but they both basically work off the same principle, just different power source. Okay, three-phase power, which like I said, you'll find in commercial buildings because it's bigger equipment. They're stronger. Three-phase is stronger, more powerful. Single-phase, same principle, but it's 2 leads and it's for smaller, weaker applications.
Just when you hear the field techs talk about it, or the guys that been in the industry more, they always make it sound like it's a different operating principle, as opposed to it's just size difference. that's the first time I've had it explained to me as a size difference. In other words, it's the first time I've had it explained to me if you need, 208 or 480, you gotta go three phase. If it's, 115, 120, you go single.
Well, there is
That's
460 single phase, and that's a whole nother subject.
Okay.
Because they take off the three phase 460, they can take two of the wires off of the, and there are 460 single phase motors, we sell tons of them. So there's 460 single phase technically. But there's no 460 single phase supply. There's only three phase 460 supply. Again, it's three phase, it's bigger wire, everything's bigger, stronger. Yeah, anytime you're talking three phase, you're talking a bigger application where you need a stronger motor. Or it's in a commercial, you'll see maybe a half horse three phase motor, but it's in a commercial building. They have three phase power, they have the ability to run a three phase to a half horse, so you use it's a better motor, it's a stronger motor. So they'll use a half horse three phase motor in a commercial building instead of a half horse single phase motor.
I get what you're saying.
Okay? Yes.
Just to get like a concept of this phase, I hear it, and this is what I'm picturing in my mind. You know how when you got your regular fan, it's got, one setting, two setting, three setting being the highest, right?
Right.
And so, a single phase would be only a motor that can only turn up to one and just stay at one.
No. This right here is a two-speed. This is a two-speed single-phase motor right here.
Okay.
This has black is high, red is low. It's a two-speed. They'll have a control, a speed switch or something in the unit that when it calls for, maybe it's a thermostat, will go into the unit and it'll call where you turn the temperature up in the house. The heating typically runs on your low speed, and the unit will send a message to the motor to run on low speed. You put your air conditioning on and you turn it up, you want air conditioning to run, the unit tells the motor it needs high speed. So the unit's telling the motor which speed to access. But yeah, no, single phase motors are multiple speed. You don't see multiple speed motors in three phase. There used to be two speed. You don't see them much anymore. They're being phased out because of the drives. With the frequency drives that they make now, you can do a lot of things with the motors. You don't need to buy a two-speed motor anymore in a three-phase.
So three phase, you don't need a capacitor to start it?
No capacitors.
So does the capacitor act like another leg, make that three leg?
No, it stores voltage, so that motor is ready to go as soon as you put power to it. It's got voltage in it. If you were to run this motor right now, put power to it and run it to check it, and if you took this little boot off and put your fingers across there, you might get shocked because now it has voltage stored in it.
Yeah, one of the phases is always have power, so one of the sacrifices is put on the circuit, so then we do electricity,
Anybody else?
Phase has to do with the electricity, basically.
Yeah, that's basically your power source, yeah. Yeah, if you got three-phase power coming into your building, like most commercial buildings do, that's your power source. Three-phase 230, three-phase 460. All right. That's it? All right. Finish the food off. You're more than welcome. Anytime, guys. Good luck in your futures.
Any motor